In this lesson, we're going to take a look at solving quadratic equations by factoring. So what we're going to be doing here is just combining two skills that we already know. So we're going to use factoring, what we just learned about factoring trinomials, quadratic expressions, and we're going to combine that with the zero product property. So remember what the zero product property says? It says that if two things multiply to be zero, then one of those things must be zero. So if you look at the algebraic notation, what we're saying is that if a times b is 0, then either a has to be 0, b has to be 0, or they both have to be 0. So we're going to start off with two fairly easy examples, and then we'll work our way up to the more complicated problems. So in the first one, we have x plus 2 times 3x minus 1 equals 0. So this would be a problem that would already be factored for you. So all we need to do is use the zero product property to solve it. So if we know that this times this equals 0, we know that one of those things must be equal to 0. So we know that either x plus 2 is equal to 0, or we know that 3x minus 1 is equal to 0. Once we split that up using the zero product property, we can then solve those equations separately. So the first one, we would come up with a solution of x equals negative 2. And the second one, when we add 1 and then divide by 3, we would come up with a solution of 1/3. So we know that x would either have to be negative 2 or 1/3. And again, remember with these, we don't know which one it is, so we need to make sure that we list both solutions because they both make the expression equal to 0. So let's take a look at example 2. In example 2, we have an expression that is not factored. However, we do have it equal to 0. So with this, what we need to do is we need to get the left side so that it becomes something times something equals 0. So if we look at this initially, we want to look for a GCF, and we do have a common factor here. So our greatest common factor of these two terms would be 2x. So let's go ahead and let's factor that out. If I factor out the 2x, I'd have 4x squared divided by 2x, which would leave me with 2x. And then I would have 6x divided by 2x, which would leave me with 3x. Sorry, just 3. So because we are dividing, we want to make sure that we're using all of those exponent rules that we had learned previously in our last chapter. At this point, I have now made it so that it's something times something equals 0. I also see that none of those expressions involve exponents, so we can go ahead and just use our zero product property and solve this. So since 2x times the quantity 2x minus 3 equals 0, we know that either 2x has to be equal to 0 or 2x minus 3 has to be equal to 0. We'll go ahead and solve those equations separately. So over here we divide by 2, and we come up with x equals 0. On the other side, you can add 3, and then divide by 2. And we come up with a solution over there of 3/2. So in this one, we know that x is equal to 0 or x is equal to 3/2. With that fraction, if you wanted to go ahead and turn that into 1.5, certainly can, since that's a nice decimal. We want to try to avoid any decimals that don't come out nicely, like 1/3. We want to go ahead and leave those typically as fractions. All right, so that kind of laid the foundation. Those were kind of more of the basic problems. We're going to now get into some of the trinomials, which involve a little bit more work. So the first one, example 3, we see we have a trinomial here, 3x squared minus 17x plus 20 equals 0. So what we need to do now is we need to use the process of factoring that we have just learned about. So with this, we want to look for a greatest common factor if there is one. 3, 17, and 20 do not share any factors other than 1. So we don't have a GCF to factor out. So the next thing that we're going to do is we're going to go ahead and start our factoring process. So remember, standard form of quadratic equation is ax squared plus bx plus c. So when we look at this, we know that our a value is 3, our b value is negative 17, and our c value is 20. So let's go ahead and start our factoring. So the first thing that we do is we multiply a times c. So 3 times 20 would give us 60. We're going to need to find factors that add to our b term, which is negative 17. So you're going to run through your factors. You're going to try to find out what's going to work. Since we're multiplying to be a positive number and adding to be a negative number, both of our values are going to have to be negative. So that'll help to start narrowing it down. when you find those factors, you should come up with negative 12 and negative 5. Negative 12 times negative 5 is 60. Negative 12 plus negative 5 is negative 17. So let's go ahead into our expression over here. First term remains the same. The second term, we're going to split into those two factors. So we'll split it into negative 12x and negative 5x. Our last term there, 20, will remain the same. And of course, we have equals 0. Since we have 4 terms, we'll now group them and we'll factor by grouping. So the GCF of the first 2 terms is 3x. We'll factor that out, which is going to leave us with x minus 4. In the second group, we have negative 5x and 20, so our GCF is 5. Now, we want to keep in mind, inside of parentheses, we're going to want a positive x minus 4. If I were to factor out a positive 5, I'm going to end up with a negative x and then plus 4 in this case. So because that's the opposite of what we actually want, we're going to go ahead and we're going to factor out a negative 5 instead of a positive. So when I factor out that negative 5x divided by negative 5 is a positive 1x. 20 divided by negative 5 is negative 4. We see we have that common factor inside of parentheses, so we'll go ahead and factor that out as one of our binomials in our final answer. And then the other one we're going to get by those GCFs that were factored out from both of those expressions. So our other binomial would be 3x minus 5. All right, so we have factored that trinomial completely. Nothing more that we can do to factor that. So now we're going to go ahead and now extend into actually solving this. So at this point, if you notice, we are very similar to the problem that we had in number 1, where we have a binomial times a binomial. So we're going to go ahead and we're going to use our zero product property here. So if we know that 3x minus 5 times x minus 4 is equal to 0, we know that either 3x minus 5 must be equal to 0, or x minus 4 must be equal to 0. So we'll solve both of those equations separately. So we have 3x equals 5, we divide by 3, and we come up with a solution there of x equals 5/3. Second one, much easier there. Just going to go ahead and add 4, and we get our second solution of x equals 4. So we know that x is equal to 5/3 or x is equal to 4. Those are our two solutions, and we are then done. As with any equation, once you solve it, you can always plug those values back into the original equation. So you can always take 5/3, plug it back up here for x, make sure that that is in fact equal to 0. You could plug 4 in for x as well, and again, make sure that it's equal to 0. So again, just combining two skills that we've already learned. We're first factoring until we get to something times something, and then we're using our zero product property to actually finish solving that. All right, let's take a look at example 4. So in example 4, the first thing we want to look for is a GCF. In this case, we do have a greatest common factor that we can take out. So we're going to factor that out initially, which is going to be 2. When I factor out that 2, I ended up with 3x squared plus 11x minus 4 left over inside of parentheses. Now we're going to need to factor that trinomial that's inside of parentheses. So we'll go ahead and start that process by looking at our a times c. In this case, we have 3 times negative 4, which would be negative 12. We know that they have to add to b, which is 11. So we're looking for factors that multiply to negative 12, add to a positive 11. Since they are multiplying to a negative 12, we know that one has to be positive and one has to be negative. So that'll kind of help start to narrow down our factors. The factors that end up working here are going to be negative 1 and positive 12. So let's go ahead, let's take that expression, let's split that middle term using those factors. So we have 3x squared minus x plus 12x minus 4. At this point, you can continue to bring down that 2 and the equals 0, or you can just worry about getting that expression factored that you have right now, and then bring those down in the end. Oftentimes, that's what I recommend because it gets a little confusing if you continue to bring those things down and kind of messes with your factoring part. So I'm just going to go ahead. I'm going to finish out this factoring, and then I'll worry about bringing the 2 and equals 0 down. So I have 4 terms. I group the first 2 and last 2 together. GCF of the first 2 terms is x. So we're going to factor that out, leaving us with 3x minus 1. In the second group, I see I have a GCF of 4. So I'm going to factor out a positive 4 since the signs are what I want them to be. And I end up with 3x minus 1. Notice common factor inside of parentheses, so we'll take that out and write that as one of our binomials. The other one we get by those GCFs that we factored out, which is the x plus 4. Once I finish that factoring, let's go ahead and bring down those other 2 pieces that we didn't want to forget. So we had a 2 in front of our entire expression, and then we had r equals 0. So we factored completely, so now we're ready to start solving. We know that 2 times x plus 4 times 3x minus 1 equals 0. So one of those things has to be 0. Now with this, one of them is kind of ruled out because 2 cannot be equal to 0, obviously. So we don't have to worry about that part, but we do have to look at the 2 expressions that contain variables. So we know that either x plus 4 has to be 0 or the 3x minus 1 has to be 0. One of those 2 binomials is going to have to equal 0. So we'll solve both of those separately, getting negative 4 for our first solution. And 1/3 for our second solution. So we know that x must be equal to negative 4 or 1/3. All right, let's go ahead. Let's continue. Let's take a look at a couple more examples. We'll finish off with a word problem here in the end, and then have some time to practice on your own. So let's look at this example 5. This one looks a little different initially because we actually have an exponent of 3 here. Now, typically we're not going to be able to solve those. However, you will notice that all of our terms have an x in common. So we can actually factor out an x from each of those terms, which will leave us with 2x squared plus 3x minus 5. Once we factor that out that x, notice that we are left with an exponent of 2. So we are actually able to factor this like we would any other quadratic equation. All right, so let's start our factoring process. So we know that we're going to need to multiply. So a times c is going to be negative 10. 2 times negative 5 is negative 10. We know that we need to add to our b, which is 3. So we're trying to find factors that multiply to negative 10 and add to 3. Again, we know the product's negative, so we know our numbers are going to have different signs. The factors that ended up making that true are 5 and negative 2. So let's go ahead. Let's split our b term using those factors. So we have 2x squared plus 5x minus 2x minus 5. Group our first 2 and our last 2 terms together. GCF of the first 2 terms is going to be x. When we factor that out, we're left with 2x plus 5. Second term, notice that right now they're both the opposite signs of what we want because we want 2 positive numbers. So the GCF of 2x and 5 is just 1. So we're going to go ahead and factor out a negative 1 since we want to change those signs. When we factor out a negative 1, we're left with 2x plus 5 inside of parentheses. Notice inside of parentheses our common factor. We're going to pull that out as one of our binomials. And then our GCFs, which we factored out, x minus 1, we'll go ahead and bring out here as well as our other binomial. Don't want to forget the GCF that we factored out in the beginning, which was x. Also don't want to forget the equals 0, which is a very important part of our problem here. So right now we have 3 terms. We have x times x minus 1 times 2x plus 5 equals 0. We know that one of those 3 things must be 0. Now this one, x could be equal to 0, so we need to consider that solution as well. So we're actually going to extend our zero product property to involve 3 different possibilities. So we know that either x has to be equal to 0, or we know x minus 1 has to be 0, or 2x plus 5 would be equal to 0. Well, this first one's already solved. Second one we can solve fairly simply by just adding 1 to both sides. And then the third one, going to take 2 steps, but with our equation skills, not going to be too challenging there. So you see with this one, we're actually coming up with 3 possible solutions. X could be 0, it could be 1, or it could be -5/2. We have to include all of those solutions because, again, we don't know which one it is. Now, one unique thing to kind of notice here, and you can kind of remember this for the future in case you ever solve any other problems like this and you want to make sure that you have all the possible solutions. Typically, remember with a quadratic equation, we have 2 solutions. The exponent on a quadratic equation is 2. Notice that this equation started with an exponent of 3 on our x, and notice that we ended up with 3 solutions. So a lot of times that exponent is going to tell you how many solutions you should have in the end. All right, let's go ahead and look at number 6. So number 6, this one, we don't have any GCF. Before we even consider a GCF, though, we have to remember that we have to make it equal to 0. We always want to make our equations equal to 0 before we start trying to solve them. So to do that, easy way would just be to subtract 14 from both sides. Since 14 minus 14 is 0 on the right, we'll then just have x squared minus 5x minus 14 equals 0. Once we get that equals 0, we can then go ahead and start factoring. Since our coefficient of x squared is 1 here, we can go ahead and take that shortcut that we had talked about earlier. So we can pretty much jump straight to our solution. We know that the first 2 terms of each binomial has to be x, because that's the only thing that they give us a product of x squared. We just have to figure out what the other 2 parts of those binomials are. So to do that, we're going to look at our a times c, which 1 times -14 is -14. We look at our b value, which is -5. We need factors of -14 that add to -5. Those factors are going to be -7 and +2. So we'll go ahead and fill those into our binomials. First one would be x minus 7. Second one, x plus 2. Again, if you're uncomfortable with taking that shortcut and jumping straight to that factored part, you can always go through this process of splitting that middle term into those 2 factors, factoring out the GCF. You can always go back to that. This is just a shortcut. If you recognize that a is 1, you can jump straight into that factored form to save yourself a little bit of time. So right now we know that x minus 7 times x plus 2 is equal to 0. So one of those 2 things must be 0. Either x minus 7 is equal to 0 or x plus 2 is equal to 0. Go ahead and solve those both separately. First one, we come up with a solution of x equals 7. Second one, when we solve, we come up with a solution of -2. So we know that x is equal to 7 or x is -2. All right, let's jump down to our last problem here. We're going to take a look at a word problem, something that we did a problem similar to this, where, like I said, it was kind of modified because of the knowledge that we had. Now that we have a little bit more extensive knowledge with quadratics, we're going to be able to solve a more interesting, more realistic type of problem. So for one of your school projects, you get to create and launch a rocket. The goal is to see who has the longest flight time, or in other words, who can keep the rocket in the air the longest. The moment comes and you shoot your rocket in the air. You didn't realize it, but your rocket was not completely straight as you watch as it lands on the roof of the school. You don't know exactly when your rocket hit the roof, but your teacher recorded the launch and is able to determine the equation that represents the flight of your rocket. The equation he came up with was h equals -4t squared plus 28t, where h is the height of the rocket after t seconds. How long was your rocket able to stay in the air if the school is 40 feet tall? Well, if you need a visual, I'll draw you one of my fantastic pictures here. So we're here in the parking lot. We got this rocket. We shoot the rocket. Now it's not completely straight. So when we shoot it, it ends up falling on the school over here. Now, if we're down here with our rocket, we can't see the top of the roof. So we don't know exactly when that's hitting. So that's why this problem is really kind of We really need that equation to be able to figure that out. So we know that the school is 40 feet tall, so that probably will come in handy at some point. All right, so we know our equation is h equals negative 4t squared plus 28t. We're asked how long it's able to stay in the air, so what we're asked for is a time, which is represented by t, which means somehow we need to find that height. Now, if you think about the starting height of your rocket and the ending height of your rocket, notice that it's going to be a difference of 40 feet since the school is 40 feet tall. So our height in this case is going to be 40. All right, well, we have an equation. We now are going to be able to solve this using what we have just discussed. So the first thing that we need to do is we need to get this equal to 0. So let's go ahead and subtract 40 from both sides. All right, once we do that, we have 0 equals negative 4t squared plus 28t minus 40. At this point, we're going to factor out a GCF. I see that all of them are divisible by 4. To make my coefficient a positive, I'm going to go ahead and actually factor out a negative 4 from this. I'm going to make it a little bit nicer in the long run, in my opinion. So when we divide all of these things by negative 4, we end up with t squared minus 7t plus 10. All right, since our coefficient of that quadratic in parentheses now is 1, we can actually use our shortcut here, and we'll be able to jump straight into our factored form. So we know that both of the binomials, both parts of my factored expression are going to start with t. We then need to find factors of 10 that add to negative 7. So since it's a positive product and negative sum, they both have to be negative. Negative 5 and negative 2 are going to be the factors that get us there. So we'll go ahead and fill in the negative 5 and negative 2. I'm going to bring down the rest of my equation. And now we're ready to solve. So we know that negative 4 times t minus 5 times t minus 2 is equal to 0. One of those things must be 0. Again, negative 4 can't be 0, so we'll kind of ignore that. We'll discard that as not being possible. We then need to look at the other two pieces, which says that either t minus 5 is equal to 0 or t minus 2 is equal to 0. Well, let's go ahead and solve those. Pretty easy equations to solve here. So t is equal to 5, or in the other one, t is equal to 2. Now, when we first talked about solving these types of equations, I mentioned that sometimes in these real-world problems, or actually many times in these real-world problems, only one of those answers will actually make sense. So if you think about which one makes sense, it might not be obvious at first. We have 2 times. My initial thought is the longer time might make more sense, but I'm not really sure. So let's talk about what these 2 different pieces mean. So remember, basically this equation, we were figuring out when the height was going to be 40 feet. So if I go back to my wonderfully artistic drawing over here, we have 2 points at which our height is going to be 40. Obviously, the landing point is going to be 40, but also if you notice earlier in the curve, when our rocket was initially going up, it passed a height of 40 along the way. So that's going to be our 2 different differences in time. This first one is going to be after 2 seconds, it's going to hit that height of 40. It's going to continue to increase in height before it starts falling. And then when it lands back on the roof at a height of 40 feet, that's going to be our final resting point after 5 seconds. So the time that our rocket was able to stay in the air was 5 seconds. All right, folks, that's it for your notes for today. Please let me know if you have any questions. And as always, have a great day.